Hello class, this is a video tutorial on primitive functions. The primitive of a function was the function that resulted in the given function when differentiated. It is also referred to as the antiderivative. So in simple terms, capital F of x is the primitive of f of x if we derive or differentiate the primitive, we come back to our given function. However, since constant terms are removed when differentiated, let's consider this. If we differentiate f of x, the 1 goes away. If we differentiate f of x in this case, the 4 goes away. And if we differentiate this one at 4.5, it also goes away. If that's the case, what is the primitive of f of x equals 2 of x? Notice how any of these functions, right, could be the primitive of 2 of x. Okay, because notice how all of these, when derived, this one, example 1, 2, 3, and 4, all of them, when derived, give the same derivative. So all of these could be the primitive of 2 of x. We must consider that the primitive of any function will always have a constant. So in general, given f of x, so we have some function, its general primitive is denoted as capital F of x plus c, where c is some constant. So to calculate the primitive of functions, we do the reverse of the power rule. If you've forgotten the power rule, it means if we have f of x is equal to x to the power of n, the derivative f prime of x is given as we reduce the power by 1 and we multiply by the previous power, so n, x to the power of n minus 1. In this case, to reverse this, we increase the power by 1 and then divide by the new power. And lastly, never forget the constant that's always attached to it, plus c. So let's do a few examples here. 5 examples to be exact. So let's find the primitive of the following. F of x equals x. Now, what function could have given us this when derived? So we denote this as capital F of x is equal to, in this case, we're going to increase the power by 1. So right now it's a power of 1. So x to the power of 2. Then we're going to divide by the new power. So dividing by 2, or you can write it like this if you want, divided by 2, or like this. They mean the same thing. This is my preferred, this is my preferred notation. Plus c, some constant. We can always test if this is correct. If we derive this, take a look, if we derive this, so capital F prime of x is equal to, if we derive this, the 2 comes down, so 2 over 2 is, well, 2 over 2 x, and we reduce the power of 2 by 1, giving us x to the power of 1, which is what we started with. Okay, this one in black is only a test that I do just to check if my solution is correct. So let's do this again. For this, we find the primitive capital G of x is given as, well, we increase this power by 1. It's going to be x to the power of 3. And then we divide by the new power. So the new power is 3. Let's divide by 3. And we multiply by whatever coefficient is remaining. So 3 over 3, x to the power of 3. So let's simplify this as just x to the power of 3. If ever you're unsure if you got the correct primitive or not, we differentiate the answer that we got here. So differentiating this, we get 3x squared, which is correct to what we were looking for. Let's do this one more time. The primitive of h of x is denoted as capital H of x is equal to increasing the power of x and then dividing by the new power. So dividing by 3 and then keeping the same coefficient in the front. So 2/3 x to the power of 3. Now, when we have a constant, oops, sorry, I nearly forgot something, plus c. There's always a constant at the end of it. For this one, for a constant to be integrated, we can think of this as x to the power of 0. Okay? Because there's x to the power of 0, if we increase the power by 1, it becomes plus x to the power of 1, which we can just ignore, times the coefficient, plus some arbitrary constant at the end. Once again, you can test if your answer is correct. If you differentiate this and we come back to our original question, you have found the correct primitive. Let's do this one more time. Now, if we have an expression that doesn't have a what's it called? A term, I guess. These were f of x, g of x, h of x. You can choose whatever you'd like in this. In this case, I'm going to let this equal to y prime of x is this, meaning the original that we're looking for is just y. And in this case, it's same deal. We increase the power by 1, so x to the power of 4, and divide by the new power. Increase the power by 1, and then divide by the new power. Increase the power by 1, dividing by the new power, and then increasing the power of 1 here. This is x to the 0. So it's x to the power of 1 divided by 1, and always plus c. I'll demonstrate another term that you can use. This is dy on dx is equal to this, meaning we can just find y is equal to increase the power of x and divide by the new power, keeping the same coefficient in the numerator. This one has x to the power of 0. We increase the power of x, x to the power of 1, times the original coefficient, and always plus c. Even when we have values such as this, we can let this one, let this be f of x, and we can simplify this as x to the power of negative 2. In this case, this f prime of x, let's find f of x, the original, is equal to, well, increase the power of x here, so plus 1, so negative 2 plus 1 is negative 1, divided by negative 1. This will give us 1 over x, negative 1 over x. One last example. In this case, I'll let this be equal to y prime is equal to this. And we can simplify this in index notation. This is x squared over, x to the power of 2/3, which means y is equal to increase the power of this. So I'm going to do a calculation off to the side. 2 over 3 plus 1 is the same as 3 over 3 which is 5 over 3. So increasing the power of this becomes x to the power of 5 over 3 divided by 5 over 3. This is where it gets a little tricky if you're working by hand. You can think of this as x to the power of 5 over 3 divided by 5 over 3, which is the same as x to the power of 5/3 times 3 over 5. And this is my final answer, 3/5 x to the power of 5 over 3. So I hope that gave you an insight into calculating the primitive of a function. Hope to see you in the next video. Best of luck.